Okay, today we got a medium problem. Swap adjacent int lr string of lr and x, move cons of, so we swap, so we can move x's around given starting string and ending string, result return true if there is a sequence of move to transform it. That's sus. I wonder why the 1, 1, 2, 3, 4. Not everything can work. I mean, I want R. Okay. So you cannot change the order, so the order of R and L have to match, I think. So, okay, so let's see. So they have same one for sure. So IJ let's call it int1 int2 for I in range n. Let's start int if start I don't equal x int1 append I if result I don't equal if R no S1 S2 S1 plus equals start I result I didn't work. Okay, so why couldn't you make this? Oh, because you, oh, so you can only move the letters L to left and R to, oh, so L to left means that, okay, so let's see, let's get back the indices. So that changes the situation, but very slightly. So let's do like in the start I result I. Okay. Now let's do for C in L R. So for L I can move it to the left, right? So if len int1 l don't equal len int2 l, return false, otherwise okay. And now what do you want to do? If int1 l I is over int2 l I, return false, and then we do similar thing. R, but just smaller, since R, wait, if it's larger, right, because we can move R only to the right, and if L is smaller, okay, otherwise return true. Default dict list. Let's see. Wrong answer. Okay, so they also cannot cross each other. What does that mean? Well, you get a okay, so what I need to keep is prefix of targets. So let's swap the order first to check this. That means that our dog of course goes wild, and so this happens, and then so it's like a j which is 0, and then max, so j is the pointer before this, and then max max target is like -1, I don't know, whatever. So what do we want to do? While j is less than int1 l I, so if j len int2 j is less than int1r and int1r j is less than I, no, int1 li, then we want to do max target equals max target index 2 rj j plus equals 1, and then we want to do like so if this or max target over index 2 li okay, that passes. Let's go. Simple logic. Okay, so letters L can only move to the left, therefore if first we have to have the same amount of letters L and R in both strings, then letters L can only move to the left, therefore each corresponding pair of L's can one from start and one from result can only be formed by xy such that x over y, where x and y are the indices of the letters L in start and result respectively. Since the start can only go to a smaller index. Okay. Same for r's, but x, y should hold since r in start can only move to the right. Finally, this is quite easy to implement, but we also have to take care of the case where such that RL cannot be swapped, which we can check by while checking else. First step, by having a pointer to R in start and keeping the maximum target R position in result for all R's in start at index smaller than the current else index if any of the sooner R's has to be moved further than the current L, then they will cross, and therefore we cannot make the strings match with the given operations. Okay, approach by of n, where n is the length of strings. We just find since we just iterate over all letters twice, 3 times, once for else and twice for R's. Okay, and do O1 work for each of them, checking the equal inequalities of n, since we store the positions of the letters, of which there are at most n. Okay, I wanted to go to bed 1 hour sooner and I still have to shower. Goodbye.